Okay, so there were questions about 6.2 in packet 6, which is about radicals and rational exponents. Okay, so the main idea here to begin with is if we have x squared, the opposite of that is the square root of x. So if we have 2 squared, that equals 4. If we take the square root of 4, that gets us back to 2. So squaring and square roots undo each other. Similarly, x cubed and the cube root of x undo each other. So if I have 3 to the third power, that's 27, and the cubed root or the third root of 27 gets us back to 3, our original base. So that's just kind of explaining the relationship. If you think about what this means, this root, so let's say the square root, and square root can be written like this, or it can be written like this with the 2. Because square roots are the most common, we don't have to write the 2, but we can, okay? So the square root of 9 is saying what times itself equals 9, or what squared. So x squared equals 9. Something squared equals 9. What's the answer to that? Well, it's 3 equals 9. Or negative 3 equals 9. We'll worry about the negatives later, but just kind of hold that thought in the back of your head for when we get to other stuff later on. For right now, we're just going to be focusing on the positive roots. So let's see, at the beginning of this, it's asking you to estimate nth roots. So for instance, they say, what's the 4th root of 25? So what multiplied the same thing 4 times is going to get you 25? Well, I don't know, but we're estimating. We don't have to know the answer. So I can think about 2 times 2 times 2 times 2 equals 16, and 3 times 3 times 3 times 3 equals 81. So it's definitely between 2 and 3. 2.1 times 2.1 times 2.1 times 2.1 is 16. I can't do that in my head. What is that? 2.1 to the 4th power. This is 19.4. So I'm just going to kind of go with 2.2. And 2.2 to the 4th power is 23.4256. So I'll just say the 4th root of 25 is approximately 2.2. So they're really just asking you, without knowing how to operate roots so much, to just think about what that root could be. All right. That's not what I want. No, this one. Okay. So then on page 300, they have these weird problems where they say n equals 3 and a equals -27, and they want you to somehow use that magically to figure something out. Well, for these problems, you're always going to be using this idea, the nth root of a. So whatever n is the root, and whatever a is the number inside the root. So for this problem, it would be the third root of -27. So what multiplied 3 times gives you -27? And the answer would be -3. Okay. Next page. Then on, let me get this back in here. Okay, then on the next page, they're talking about evaluating. So this is when you're actually finding the answer. Like, in their example, they have the third root of -8. And again, this is on page 301. Of unit 6. So we have the third root of -8. So what multiplied 3 times, it has to be the exact same thing all 3 times, is going to get us -8. This is going to be -2. Because -2 times -2 is +4, times -2 again is -8. So the answer is -2. And then they have 16 to the 1/4. This fractional exponent is just another way of writing a fourth root. So this is the same as saying the fourth root of 16. So again, we're thinking what multiplied 4 times is going to get us 16? Well, the answer is +2. So the answer is 2. Okay. Okay, so then when we get down to example 3, toward the bottom of that same page, it gets a little tricky. So we have a, which is 16 to the 3/4. Well, this is saying we take, let's see, one way of looking at this is it's the fourth root of 16 to the 3rd power. So the fourth root of 16 we just said is 2 to the 3rd power, which is 8. Okay, that's one way of looking at it. Another way of looking at it, if we take this 16 and break it into 4 pieces, the bottom tells us how many pieces, and so what 4 times makes 16? Well, it's 2 times 2 times 2 times 2. And then the top tells us how many of those pieces do we want to keep. So I want to keep 3 of those 4 2's. Well, 2 times 2 times 2 is 8. So that's a different conceptual way of thinking about that. And then they get into application and practice. So I think I'm going to leave it there for now. And then if you have more questions or specific questions, let me know.